Algebra, Unit 6, Lesson 3, Notes 4, Solving Systems of Equations by Elimination, Day 1. It's best to use the elimination method when you have coefficients that are either the same or opposites. To solve a system of equations by elimination, first you need to have the coefficients of either the x or y term to be the same or to be opposites. Then you simply add or subtract the equations vertically, up and down. This will allow you to solve for one of the variables. Lastly, plug in the value you found into one of the original equations to find the other value. Be sure to state the solution. Solve the system of equations by elimination. So if we take a look at letter A, I'm going to notice here we've got x and x. They both have a coefficient of 1. I also notice that I've got positive 1y and negative 1y. If at all possible, you want to deal with variables that have opposites for coefficients. If not, we'll talk about that later. So basically what I'm going to do, you first need to also make sure that your x's are lined up, your y's are lined up, your equal signs, and your constants are lined up. All we are going to do is simply add them. So we have 1x plus 1x, which equals 2x. Positive 1y minus 1y cancels out. Carry down your equal sign. And 10 plus 20 is 30. Now I'm left with a very simple one-step equation. I'm going to divide by 2 on both sides, and I get x equals 15. This next step is the same. You're going to pick it as before. You're going to pick an equation and plug in our x value. I'll just pick the first one. X plus y equals 10. I have x, which is 15. So 15 plus y equals 10. Subtract 15 to get y by itself. And I get y equals negative 5. So the solution here is my x value of 15, comma, y value of negative 5. B is very similar to A, so go ahead and do that one on your own. Letter C. I wanted to do this one because it has some fractions in here. Okay, so let's investigate a little. I definitely have x's, y's, equals, and constants lined up. X and x have the same coefficient. Y's have opposite coefficients, which is what I like to see. So I'm going to add 1x plus 1x is 2x. Positive 1y minus 1y cancels out. Bring down the equals. 2/3 plus 1/3 is 3/3, which equals 1. So I'm just going to rewrite this as 2x equals 1. Let's solve for x by dividing by 2. X equals 1/2. Pick an equation. I'll choose the first one. X plus y equals 2/3. I have 1/2 for x, so 1/2 plus y equals 2/3. Subtract 1/2. You can go ahead and use your graphing calculator. You can type in 2/3 minus 1/2 and use math enter or math enter, and it will give you a result of 1/6. So y equals 1/6. So the solution to this system, or in other words, where the lines intersect, are at 1/2, comma, 1/6. Let's look at D. Okay, this time our x's, our coefficients are opposites. Y's are the same. The equal sign is lined up, and so are the numbers. It looks like mine is a little spaced over a little more, but yours should be pretty lined up. Okay, let's go ahead and add. X minus x cancels out. Y plus y is 2y equals 7.2 plus 4.8 is a nice 12 even. Divide by 2, y equals 6. I'm going to plug into the first equation. You can choose either one. X plus y equals 7.2. Y is 6. X plus 6 equals 7.2. Subtract 6. Remember to line up those decimals. X equals 1.2. So this solution is 1.2, comma 6. That's where those two lines intersect. You should be able to do E and F on your own, and let's go ahead and flip to the back. Letter G. I'm definitely lined up x's, y's equals constants. This time I have coefficients that aren't 1 or -1. 4x and 5x are neither the same or opposites. However, I have +2, -2, which are opposites. And when they're opposites, we can just go ahead and add up and down. 4x plus 5x equals 9x. The 2y and -2y cancel out. And we get 9x equals 32. Divide by 9. X equals. Now, if you were to divide 32 divided by 9, you would get a repeating decimal. I don't want you to use repeating decimals. Keep it as a fraction. Keep it as an improper. You can do on your calculator 32 divided by 9, math, enter, enter, to see its simplest form, which in this case is still just 32/9. Leave it that way. If you want to change it back into a mixed number, you can, but it is not necessary. Pick an equation to plug into. I'm going to go ahead and just use the first one. 4x plus 2y equals 16. I'm plugging in 32/9 for x. So 4 times 32/9 plus 2y equals 16. 4 times 32/9, I'm definitely going to use my calculator and do math, enter, enter to keep it as a fraction in simplest terms. So it would be 128 over 9. Bring down everything else. Plus 2y equals 16. Subtract 128/9 from both sides. In your calculator, just plug it in. 16 minus 128 over 9. Math, enter, enter. We get 2y equals 16/9. Divide by 2. We get y equals. In your calculator, make sure you put 16 over 9 in parentheses. Then divide by 2. Hit math, enter, enter. And we get 8/9. So our solution here looks a little strange. We have 32/9, comma, 8/9. This is a good example of if we were to graph these, we would not have the point of intersection in a nice ordered pair. It would be kind of in the middle, not in the middle, but it wouldn't be exactly on lines and grid lines. So this is a good example of when it's a nice idea to solve it algebraically rather than by graphing. Okay, let's go ahead and skip to letter J. All right, so we have 8x and -3x. They're not opposites, they're not the same. We have +y and +y. This time they're the same. We've dealt with everything so far that were opposites. So this time they're the same, and we'll discuss what to do with that. My equal signs are lined up and my constants. Now, If they're the same, you can subtract. However, oftentimes I see a lot of mistakes when we just subtract. So here's what I'm going to tell you to do instead, and this will help lead into tomorrow's lesson. I'm going to take one of the equations, it doesn't matter which one, I'll choose the second one, and I'm just going to multiply the whole thing by -1. What's going to happen is it's going to then make this y a negative y, which will give me my opposites. So this first one I'm not touching, so I'm just going to rewrite it. 8x plus y equals -16. The second one, I'm going to distribute this -1. -1 times -3x is positive 3x. -1 times positive y is negative y. And -1 times -5 is positive 5. Basically, all it does is it changes the sign of everything, every term in this equation. And what happens is great because it actually helps me cancel out the y's. 8x plus 3x, and now I can just add, is 11x equals, and -16 plus 5 is -11. Divide by 11, we get x equals -1. Choose an equation to plug into. I'm just going to choose the first one. 8x plus y equals -16. Plug in -1 for x. 8 times -1 plus y equals -16. -8 plus y equals -16. Add 8. Y equals -8. We get a solution of -1, -8. Let's do one more like it. Let's look at letter L. Letter K is also like this, but let's do L together. Okay. So in letter L, the x's are lined up, y's are lined up, equal signs, and constants. So we're good to go on that regard. Now, we've got with our y's, we don't even have the same or opposite coefficients, but with our x's, we have the same coefficient. So here again, I want to multiply one of the equations only by -1. This time I'll choose the top just to be different. It doesn't matter. So when I multiply everything by -1, it just changes the sign on everything. So -1 times -6x is positive 6x. -1 times positive 6y is -6y equals -1 times 6 is -6. Bring over this equation, not doing anything to it, just rewriting it. Now I can go ahead and add. Those cancel. I am left with -3y equals -18. Divide by -3, y equals positive 6. And I'm going to go ahead, just to be different, let's plug into the second one. -6x plus 3y equals -12. -6x, I have y over here, so plus 3 times 6 equals -12. -6x plus 18 equals -12. Subtract 18. -6x equals -30. Divide by -6. X equals 5. So the solution here is 5, 6.